And that's good. Uh, we'll deal with the quiz at a later point of time. Okay. I want to finish certain things today. Today is the last day for low-level programming, and I also would like your cooperation, folks. Please take any questions you have uh, about this particular course, content, assignments, whatever, and put it on the channel because um, the uh, if you send me texts, I mean, I actually get like 300, 400 texts, right? Unless they are kind of categorized, it's going to be difficult for me to respond to you guys, right? Not because I don't want to. When you get the stream of messages, it's impossible to just answer to one person and not answer to everybody, right? So if you put it there, then others can help you, I can help you, and it makes it easy for all of us to cooperate with each other given the circumstances, right? And proceed forward. So don't send me anything and don't be shy to put something on the channel. If you put something, it means other people have that particular problem too. So did I share my screen? Let me see. Okay, I'm sharing the screen and I want to just tackle first the particular question that was sent to me, right? Can you guys see my screen?
No.
No.
No,
What's
no,
going
we
on?
don't see anything.
Can you see now? Any?
Still no, Professor.
Okay.
Yes,
Uh,
yes.
Okay, yeah, yeah. Now
Now
can, now
can.
we can see. Yeah.
excellent. So I wanted to show you guys a question I got, and the question relates to the problem with unions that variance in C++17 solve, right? So the question was, hey, you're saying here that S is getting constructed, but you're also saying that S and S2 share the same memory. So wouldn't S2 also be constructed? Um, that is going to be true if S and S2 were simple objects like ints and floats and so on. The point here is that S is a complex class-based object which relies on constructors to encapsulate C-style strings. So when I do something like this, the rule it from right from the early days of C is that the first data member is going to get initialized. So we are forwarding this particular C style string to the constructor of the first data member, right? If there was float, for example, as the first, then this entire thing is going to be in error. But since this guy can take a constructor that is of this type that you see here, the C string hello, S is going to be constructed. The problem is that S2 uses the same memory, but S2 in a sense is not really constructed, right? The object itself is not constructed. S is the one that is constructed, even though they share the same memory. So if you use S2 to do anything, then potentially you're middling around with S. So you can either use S or S2, but you can't imagine that just because you initialized S and S2 shares S's memory, then you can go ahead and use S2 because whatever you do with S2, you're doing with S's stuff. And that is considered incorrect because the whole point of creating classes, in our case, a string based object or a class based object string, is that each one individually encapsulates. And that is what users will expect. So we shouldn't touch S2 because in a sense, it's not constructed, right? It simply is going to be using S's information, S's data, and so we are uh, sort of it's undefined behavior. It's just going to work or not work. It completely depends on the underlying compiler and machine. Okay. Am I making sense? Did you guys understand why we can't do uh, why we can't simply because we initialize S, we can just go ahead and use S2. And then I showed, sorry?
Yes, we get it.
Yeah. So and so if you want to do something like that, the variant is considered the new modern alternative to your union. Okay. And the only thing I haven't shown you is inheritance, but I'll do that later on when we deal with inheritance, because variants can allow you to implement inheritance without inheritance. All right. So that is interesting. Okay. So today's lecture, I just want to bring to an end this whole low level stuff, right? We should be done today and then move on to more interesting things. What are the things I want to tackle? Well, uh, we have seen in HLP one C-style text-based stuff and HLP2 C++ text-based stuff. But binary file IO, at least from my perspective, wasn't shown in any one of the tutorials, labs, assignments, and so on. And many of you are going to work in computer games where a lot of data could be potentially encapsulated as binary files. So I want to just run my way through because in the summer I noticed certain students were having trouble with this concept. So I made a note to myself to talk about it. The other thing I also noticed is that many of you seem to be unaware of scoped enumerations, which is not a good thing because enumerations are user-defined types. So you can implement your UI in a much more simpler fashion, right? If you use the modern scoped or yeah, I will just call it scoped enumerations. Then the last thing I want to do is go through a sort of like a jumble of things that relate to complex declarations. That includes 2D arrays, 3D arrays. How do you take a one-dimensional array and think of it in terms of 2 dimensions, 3 dimensions? How do you pass a 2-dimensional array to a function, 3-dimensional array to a function? What about pointers to function, arrays of pointers to functions? What else? And sort of taking pointers to functions and composing higher order functions. Quite a jumble of stuff. And then finally, how to read complex declarations. That is important because you are at this point in your third programming course, so you should be able to read anything out there in terms of its declaration, right? And it shouldn't uh, sort of confuse you. All right. So there's going to be quite a bit of coding today, not too much in terms of slides. But the reason I'm making these slides is that I stay on target, right? And then I already have the source code. The only reason I don't put the source code is that I may make changes, or I may all of us will find out there's some error. So afterwards, I'm going to put everything in. And at around 10:30, I'm going to stop and we'll go to the quiz. Okay. All right. So text-based files is the sort of default mode, both in C and C++, right? And this is what's going on. So we looked at bits and how data is stored in the bytes associated with these objects. So if you have a byte or a short or an int, we didn't actually look at the IEEE 754, but you looked at it in some other classes. So data is represented in memory using certain conventions, right? And what we do when we use when we deal with text files and we deal with uh, uh, the streams that are part of both C and C++ is that with text files, the iStream and OStream, what they do is they take the binary representation of whatever object you have, let's say an int. It is stored internally using a representation such as the 2's complement. And it's going to convert that into a variable size sequence of characters. The characters are ASCII, right, for our purposes today. And so in numbers such as 1, 2, 3, as you can see here, when put into a file is going to take 3 bytes because 1, 2, 3 is represented in memory in 32 bits using the 2's complement representation. But when you put it into a file, the streams are going to convert the binary representation into, in this particular example, a sequence of 3 characters. And that would be the ASCII encoding for 1 followed by 2 followed by 3. So that's what you would see in memory, right? I just wrote them as 1, 2, 3. Now variable size, because if the 32-bit number was a bit longer or larger, 1, 2, 3, 4, 5, 6, then the text file would contain 6 bytes of information, because even though in memory you had 32 bits for both 1, 2, 3 and 1, 2, 3, 4, 5, 6, in a text file, the first number is going to take 3 bytes. The second number is going to take 6 bytes. The difference between a text file and a binary is that in a binary file, you're taking the 32-bit pattern of 1, 2, 3, 123, and putting it into file exactly with the same bit representation, right? So as this picture illustrates, 1, 2, 3 is going to take 4 bytes, which is a byte larger in a binary file than a text file. But 1, 2, 3, 4, 5, as you can see, is also going to take exactly 1 byte. While if it was stored as a text file, it would cost you 5 bytes. That is the only difference. So somebody internally is converting binary representations into sequences of characters. And when you want to read from the text file, somebody is automatically converting those sequences of characters into the corresponding binary representation associated with that object, right? As long as you remember that, everything is going to work fine.
What about
So go ahead.
text files also have the line break character, the new line character as well, right? Sometimes.
Not necessarily. You can just store 100 characters, 100 numbers such as 1, 2, 3, 1, 2, 3, 4, 5, 6, as long as you separate them using any form of white space. It doesn't have to be a new line. Now, text files are meant to be also human readable, so you may put them on a new line. But if you don't, then you have one single line stretching from the left all the way to the right, and you have to kind of shift your text editor to the right rather than to a new line. The number of bytes is still going to be the same because a space will take exactly the same byte as a new line. Did I make sense?
Yeah, but sometimes like in the hex, they might convert like a new line or binary to a new line by accident.
Well, in binary, you don't represent. So okay, we'll write some code to understand this, but the question being asked is pretty interesting. So if you had 2 numbers, 1, 2, 3, 1, 2, 3, 4, 5, 6, how would you write them? Let's say if you're writing them in the text form. Well, you would write 1, 2, 3 and provide some white space to separate 1, 2, 3 from the next number 1, 2, 3, 4, 5, 6. Why are you going to do that? Well, that's how the standard streams behave. If you say, hey, I want to read a number, then the machine is going to read whatever characters you type in 1, 2, 3, and then you press the enter button. It says, oh, the number of characters that you have entered is 1, 2, 3. I'm going to take these 3 characters that are in ASCII and convert them into the binary representation of 1, 2, 3. Or if you are trying to read a number, you can enter 1, 2, 3 followed by a non-digit character such as A. And the scanner that is scanning these characters is going to say, oh, I'm going to stop because the user is providing me a non-digit number. So anything that is not a digit can separate 1, 2, 3 and the following number in a text file. In a binary file, every number, okay, is going to have a standard representation, which in our case, let's say, is 4 bytes. So 1, 2, 3 is going to be stored here, and the next number is going to be stored right here. And you're going to read these 4 bytes and interpret them as an int, right? And then you're going to go here and interpret them as another int. So this guy could be written in the next set of 4 bytes. And so they can be tightly packed. And that is the reason why binary files can also sort of give you better memory savings in terms of the number of bytes required to store these numbers. And IF stream, oh, sorry, there was a typo. So IF stream, OF stream, and F stream, okay? They do the text-based stuff automatically. So whatever you type in a sequence of characters you want to write a sequence of characters, then they automatically either convert the sequence to the appropriate object or take the object, its bit representation, and convert it into a sequence of characters. And so that's the default behavior, right? You don't need to do anything, and that's why text-based I/O is at a higher level than binary I/O. Binary I/O, you got to worry about, you know, casting and so on and so forth, because the system has no particular interpretation of your data. It's just going to read byte followed by byte followed by byte without caring about what the underlying information might represent. So we tend to make iStream and OStream just copy bytes without doing the work that they do, right? In terms of converting sequences of characters into the appropriate bit representation, we simply say, when we say binary, when we pass this, when we open a file, this particular flag, we are simply saying, hey, don't do that conversion. That's all there is, right? So what I'm going to do is just quickly show you, because part of this week's assignment is for you to deal with binary files. I think of it as a low level thing. And it's a pretty good, interesting sort of real world exercise. So I do want to show you maybe how this whole thing works. For all the rest, maybe we don't have time for me to write code, so I'm going to actually show you the code. So here I am. So let's say I just call it fileio.cpp. And can everybody see my code, guys? Is it big enough? There.
I can see.
Yes.
Right. So what I'm also going to do in this particular thing is not just look at IO, okay? I'm also going to show you certain iterator adapters. We looked at them in the very first class, but this is a good opportunity to kind of see how we can take advantage of other things in the standard library to get our work done, right? Rather than sort of try to do them separately, and then you know, sometimes it's hard to be able to show the practical advantages of certain things. So here I can actually do that. So and if you already know file IO, that's fine. But I'm also going to talk a little bit about algorithms and iterators. So let's say we want to use strings. So I'm going to hardwire, let's say, the file name. Maybe I'll just call it file name. Let's say we start with the text file, okay? Actually, I'm going to remove the const because later on we'll change this to something else. All right. All of you probably know this, but I'm going to just go ahead and write a bunch of character strings to text file. So let's kind of do something like this. Santiago. Never been there, but I heard it's quite pretty. Okay, and all we need to do to write this to a file is simply to provide the name of the file. Remember, you don't need to do anything more, okay? Because by default, they are programmed to deal with text. And so they're going to take these guys and convert them to variable sequence. Well, there's nothing variable about them. If you actually count the number of characters, you'll see that my file is going to contain exactly the same number of characters. All I have to do is just go ahead and do something like this. That's it. And then I close. And if you have many strings, then you have to provide a new line, as Clementin was talking about, right? To separate them. But if you don't provide a new line, then what's going to happen is that you don't know sort of how many words there are in each line. And then the get line function that you are familiar with is going to have trouble, right? Because it thinks of, if you want to put these on individual lines, then you may want to kind of think of something a little bit different, which is create things like this. And then copy the contents of, copy the contents of this array into the file with each string in a new line, right? And so this, we'll think about it later on. I just want to show you that the file gets actually created. So let's go look at it. What's the name of the file? Test. So it's got 33 characters and it looks reasonably correct because it seems like these guys end up with 33 characters. Now, what if you wanted to write each one of these is a great city. Singapore is also a great city. I'll just do this. Is a fine city. Yeah, just the usual joke. Okay. So you want to write each one of these to a new line? No problem. What is the best way to do this, guys? First, we already kind of dealt with this, so everybody knows. So what I'm going to do is I'm going to open the file again. All right, we can close and open as many times as you like. And what I'm going to do is essentially call the open function and say, hey, open it for me. Now, here's the beautiful thing. right? When you have this particular sequence of characters or strings, it's pretty trivial to write them to the file that we just opened if you take advantage of the library. So watch what I'm doing, right? There's not a whole lot to explain except being aware that there are these things that can make our life useful. So many times we start open iterating through each element. For example, let me go ahead and do that. For something like this is something that sounds familiar to all of you. What we can do is we can say X, and then I follow that by a new line. Okay, and then we close. So this is not an unreasonable way to do it up until HLP2. But in HLP3, we don't want to do this. So what's going on? File name is, oh, did I compile? And then let's look at the listing 95. I don't know, it sounds reasonable. It went up from 33 by a factor of 3. Maybe, yeah, I don't know, guys. The best way is to read the file. So I'm going to do that here. And you can see, yeah, we got all the lines sitting in the text file. But maybe the better way to do this is to constantly practice your skills in terms of the standard library. All of you know that in the standard library we have the copy algorithm, right? We have used this before. It's one of the most fundamental algorithms. And what it does is that this one is sometimes a little bit harder to read, so I'll just show you this. And what it does is that it essentially takes the range of the source and the starting point of the destination and pretty much dumps everything in the source to the destination. Well, the way you want to think about streams, files, is that, they're no different than a range. And so once you open the file again, then why don't we just go ahead and, use the output file, which is empty, and treat it as a output range. So we start with the source range, which is the vector. And now we want to specify the file. And the way to do that is to go into the library and look at iterator. Okay, it's got a lot of interesting stuff, but the only one I'm going to show you is the iStream or OStream, because that we are writing. So the OStream iterator essentially is an adaptation of the output iterator. Remember, there are these categories that we learned in HLP2 for iterators. There's the input iterator category, there's the output iterator category. These are obviously related to C in and C out, right? Those objects essentially implement these. Then we have the forward list. That idea of being able to move only forward in the singly linked list, but never backwards, is defined by the forward iterator category. Now with the doubly linked list, we can go forwards or backwards, read and write at a particular node as many times as we like. And that is defined by the, what's the name? Bidirectional iterator category. And then the vector or the array, they implement what is called the random access iterator. So these are the 5 that the library is giving us, but the library also provides adaptations of this. What does that mean? For example, the stack is a container, but it is an adaptation of the deck, or if you wish, of the vector container that already has been defined. So these guys were defined for convenience for people like you and me to make it easy for us to read and write to and from files. So I am going to use that particular adapter, which is the O stream iterator, right? I don't want to do any of this stuff. I simply want to use the standard library. And what we do here is we say, well, the output iterator stream is going to write objects of type string, right? And it's going to be tied to OFS because that is the file that we are treating as the output range. And uh, mm, and how do you want to separate each one of the things? Actually, I think I need to provide the output iterator like this and specify this because copy can only have one destination range. So this is basically saying, hey, I want to treat my output file, which is as soon as I open empty, and create an iterator that allows me to write each element specified by the source range. And after I write that particular element, I want to automatically put a new line. Does that make sense? Everybody? And
Yes.
and all I need to do is essentially close it, and you should see pretty much the same thing that we did earlier happen. And remember, anytime I open a file, its previous contents are gone. So I'm not sort of reusing the old stuff. So let's actually, anytime you use these iterator adapters, make sure to include. Otherwise, you get a whole bunch of errors. And sometimes, as you've seen me, right, it's kind of complicated. Uh, oh, there. All right, let's run the program. Let's look at the output and look at the thing. So this is pretty useful. Always remember that files can also be treated. And if you want to print this to the standard output, all you have to do is just this. And because the standard output is a stream too. And so when I run it, you can see that it prints not to the file, but instead to this. And so that is good. All right. Um, Now, when you are dealing with numbers, so I want to go away from text files because you guys know your text files well. Uh, let's say I have a vector. So dealing with binary files. So let's say we have some sort of big numbers because I want to show you how the size of the binary file and the text file change, right? And why it is so important to kind of understand what a binary file means. So here I have a vector of integers, and I'm going to choose some big numbers so that we get a sense. So this one is 4 characters. I'll choose another one that has 5 characters, and then I'll choose another one that has 6 characters. Okay, so clearly, actually, I'll throw in another one too. 3579357. Okay, so 4, 5, 9, 6, 15, 7, 22. So if you store this, information in a text file, you're going to get 22 bytes. Okay. How many bytes if you store this as a binary file? Guys? If I store this information in the form of a binary file, how many bytes would that particular file be? Come on, guys.
16.
16. Excellent. All right. So let's go ahead and do that. Write numbers to binary file. Guys, don't tell me text. I can't concentrate on making sure that I don't screw up, because it's quite embarrassing when you see me have nothing but errors when I compile and also talk, and then you guys send me these notifications. It's not going to work, right? I'm kind of smart, but not that smart. So the same file that we opened as a text stream, right? We can certainly open this now in the form of a binary, right? So what I'm going to do here is, since we're going to deal with binary files, I'm going to change file name to be bin, right, for binary. And we just go like this, and we provide an additional flag because we are going beyond the default behavior. And this particular class is anyways going to be included when you add fstream, so we don't need to do much. So fstream takes care of both istream and ostream. And all we need to do is we need to say, hey, I'm going to now ask you to stop the conversions that you have been doing and instead treat everything just based on bytes. Now, all of these formatting that you see in terms of write strings, read strings, it's not going to work with binary. Binary is pretty low level. All it's going to do is read a byte followed by another byte. And we're not asking it to interpret. So a lot of the standard algorithms are not going to be that useful, right? Because the behavior of binary files is going to be quite dependent on the underlying platform, operating systems, and so on. So this is completely portable, but things related to binary files may not be completely portable, right? So that's why we think of it as low level. So I open the file, and the only way it seems to me that I can write is essentially to kind of go through a loop. Questions? So we already have an array of, or a vector of ints. So I'm going to take this, and you have to use the low level, similar to the F write that you are familiar with from C, and ask the compiler to take the int value that is stored in this particular variable and convert it to a char pointer. So we provide the address and essentially say, okay, assuming the size of an int is 4, right? If you are not interested in making any assumptions, then do what we've kind of suggested in the early part of the semester and simply say, hey, this is what I'm going to do, right? And these are always going to be 4 bytes. So pretty low level, isn't it? So basically what I'm saying is I have 4 bytes of information. This guy can only deal with bytes, OFS, now that we are asking it to be in binary mode. So we are saying, OK, take this particular 4-byte value. I'm giving the address of the first byte of this 4-byte value. That is what this entire expression says. And then I'm saying, think of it as an array of 4 chars and dump that stuff into a file. Okay. And notice we don't need new lines or anything. We're just going to dump 4 bytes followed by 4 bytes followed by 4 bytes. And once we are done, we're going to close. All right. And we're going to run our code. Sorry. We're going to run our code. And I'm going to open the file. Generally, your text editors are going to complain because it just contains nothing they understand in terms of ASCII or UTF-8. So I say, yeah, I want to open it. And you get some crazy stuff, right? But that's really all there is. If you have an hex editor, I always make sure that I have an hex editor because I like my own debugging thing. So you can kind of open this file and then observe. So there are many hex editors. So make sure you always have one so that you can analyze the contents of a file like this. See, compared to, let's go back here. If I had taken this and written it to a text file, it would have looked like this. And again, we use the OStream adapter, except instead of strings, I'm writing ints. And this is quite important. You got to put some space, whatever you want. If you don't, you're writing a whole set of numbers. And when you read the file, well, there's going to be overflows, right? So you will see that this one does the proper thing. So now I'm going to go ahead and show you the size of the 2 files. So the binary file is 16 because I'm writing 4 ints. Each int is 4 bytes. But notice that the text form has 26. We have to add the 4 spaces. And then there is a variable number of characters. So one number is going to be potentially going to contain, well, actually this guy is going to contain 4 bytes plus the space. This guy is going to contain 5 bytes plus a space, 6 bytes and a space, 7 bytes and another space. So that all adds up to extra memory being used. So that is how things work. Any questions, guys? Now, let's say we want to read the binary numbers that we stored. Obviously, reading the uh, the uh, text files, dealing with the text file, I just want to show you how easy it is to open the text file. So here I go. I'm saying I want IFS to be the input stream, and I'm going to give it the name of the file. And I want to read. And it's pretty simple, guys. So remember this vector. I'm going to sort of essentially create a duplicate of this in one single line, right? I'll call it VI2. And notice all we need to do is essentially create an iStream adapter. This is the O stream. Well, if I can write into an output file, thinking of it as a range, I can treat a already created file, which is open for reading, as an input range. And the constructor for a vector allows us to do that. It allows us to specify a range. So that's exactly what I'm doing, right? It's single line, and it's going to look like this. So this is the input starting point, begin. It's initialized to be at the where the first character occurs in this input file. The end is obtained by default constructing an iStream iterator like this. And this essentially fills up VI2. So if you have a big file containing lots of stuff, I mean, I think reading files, C gives you the most speed, right? Because it's really raw. But this is not bad because you don't have to do anything. The vector gets constructed automatically. And to confirm that, again, we use the copy, one more line, and we simply say begin and end like this. And then we, you know, do this thing that we um, did, except that now we are going to put it into the output stream. Okay, so pretty simple and straightforward. Let's confirm if that everything is working. Uh, and you can see the numbers being printed, right? So it got read into a vector. So everything that we have been doing so far makes sense. So this is kind of how, you know, if you're doing text-based IO, there's better ways of doing it. And so I'm going to move on from there. The only thing is, once we write numbers to a binary file, how are we going to read it? Well, there's no way we can do it as simply as we did with the other stream. So read numbers from binary file is simply going to look like this. This one we close. Did I close the iStream? No. So I'm going to go ahead and close the input stream so that we can reuse. Just to show you that you don't need to create new objects, right? Open file name and in binary. Okay, all right. Now, how do I read this? No easy way. So unfortunately, the only way, in my opinion, that is sort of reasonable looks like this, guys. I normally do it like this. I just dump everything into a for loop, right? So again, we are doing low level stuff. So we know, you gotta know that this binary file contains 4-byte ints. If you don't, there's not much you can do, right? That's why, as I'll soon show you, every binary file out there, audio, video are the most common, and pictures. They all contain detailed specs to explain to somebody who wants to read the data how the data is constructed. If you don't know anything about what the data is in a binary file, there's no way for you to know. At least with a text file, I can open the file and get a sense. So binary files, we know that it contains numbers, so that's why I'm doing what it is that I'm doing. So I'm going to take the variable X into which I want to dump each one of the numbers that I'm reading. Excuse me. And I'm telling the read function, hey, each one of these objects that I want to read is sized 4 bytes. Right, so it gets the pointer to the first byte of X and dumps 4 bytes. Now this is where things get complicated with little endian and big endian, right? So you got to be really careful. What machine and what data? If you're getting data from the network, TCP/IP, for example, has a standard big endian. If you are taking a file that was created on a big endian machine and you are bringing it over, well, you're going to have a problem. Or you're creating a file on a binary file on a little endian machine and taking it over to a big endian, you're going to have a problem. Portability, right, at the lowest level is not a given. So in my case, everything was created on the same little endian machine, so I don't have any issues. And basically, I'm defining this guy in the condition I read. And the idea is that IFS, when it reaches end of file, is going to terminate because it evaluates to false. IF read returns false. And the only thing left to do is, I suppose nothing, right? And so this is my one liner that allows me to read the entire file, right? And obviously, we want to store these things somewhere. And so let's go and put it in VI2, right? VI2 clear. This is quite important. VI2 contains 4 integers. I'm clearing it out. So the size of VI2 is empty. Now we have to push back, right? And so the way we want to do it is we want to take the thing and simply say push back X. And then after you're done, VI2 is going to contain the 4 characters, and we can again print by taking this and dumping it here. So we should see 2 sets of the same numbers being printed to the standard output. There. Now, I also want to show you another variation. Let's say we have this array. We filled it. We can confirm that it's filled. I want to show you. I know we are doing file IO, but I want to show you one cool thing, again, related to iterators. Let's suppose I have a vector called VI3. VI3 is completely empty, right? What I would like to do is to copy from VI2 to VI3. Now, let's say we do it like this. And then I'm going to go ahead and print the contents of VI3. My question to you guys is this code going to work? If yes, why? If not, why not?
No.
Okay. Correct answer. Can you give us the reason?
Your vector begin is size 0. It's not.
Excellent. Basically, this guy is empty, okay? It's default constructed. So this thing will work only if there is space or room in VI3 for 4 ints, but there is none. We can see that. So what we really want is for that particular destination to actually be told that it needs to push back. So how do we do that? Well, there's an adapter for that, like most things. And it looks like this. The simpler one is just called back insert. Right? So what it does is that it reformats the iterator, which we gave as begin, to actually push back And the way it works is you replace this with back inserter, and this iterator adapter is actually going to use pushback on the destination. So it's going to read a value from VI2 and it's going to push back, right? If we had just begin, then what it would do is it simply is going to take the iterator and it would look like this. I'm going to just quickly give you an idea. Template, type name, input iterator, out template, type name, out iterator. So this is, I'm writing my version of the copy, guys. So in iterator is start, in iterator is end. So that would be these two guys. And this one would be, some other iterator with certain properties. And let's call it destination. So how is this implemented? Well, basically we go from start until we get to the end. And at each step, we're going to do something like this, isn't it? What our friend who gave the answer is indicating is that, hey, there's no memory. So you're dereferencing potentially the null pointer. And so the whole thing is going to crash. So what we really want is some sort of pushback to be used on the destination, right? And that is exactly what the back inserter is going to do. So I'm going to get rid of all of this. And rather than a crash, now there's a better ending to the story. And you will see the numbers being printed again. The third time, right? So, OK. All right. I think that gives you kind of hopefully a good idea. And what I'm going to do now is very, very quickly, OK? Show you, because many of you are going to deal with binary files in the real world. And I kind of have an assignment, not related to BMP files, but something else. Top secret until the quiz is out. And I'm going to show you my how simply you can go ahead and use your basic knowledge to quickly parse things in the real world. Right, so we have a BMP file. What is a BMP file? It's I believe, a file format invented by Microsoft. So it works well on a Little Indian machine because Microsoft's were, mostly related to Intel, and so the, I just go to Google, I suppose, and look at the file format, right? And obviously, if I give you something as assignment, and you look at this and say, well, my God, it's too much. So you got to know what to look for. The very first thing is, from what you know now, we need to know what kind of data and how that data is stored. So that in every binary file format is going to be stored in a file header. So we need to, essentially quickly, if you are interested in speed, you would essentially jump there. And what this header, apparently it's how many bytes? This seems like 14 bytes from what I can see, right? And one of the things that gives you is apparently there are many kinds of BMP files. There's Windows. This is OS2 that is really, really, really old. So most of the newer files, you don't even need to worry about it, right? It will probably be BM. And I know that I have BM, so I'm not going to worry about this. What I'm interested in is the size of the BMP file in bytes. Why? When you read a BMP file, you're going to obviously have to allocate memory. So you need to know how many bytes there are when you open the file. And then you need to know, obviously, if it's a rectangular format, you need to know the width and the height. I don't see the width and the height here, but what I see is where the actual pixel data is stored. Okay, and the pixel data itself can be stored in many ways, but I've simplified it to be RGB, 24-bit. Okay, so where do we find the width and the height? We actually scroll a little bit down. Excuse me, and you kind of see bitmap width in pixels, bitmap height, or you can do a search on the web page for width and height. And since we don't care about OS2, we care about Windows bitmap. So it seems here that at an offset of 18 bytes from the start of the file, okay? You're going to get 4 bytes that give you the width. And at 22, at an offset of 22 bytes from the start of the binary file, you get the height. And there's a lot of other information, but as I told you, we know that the size of the file is uh, uh, the pixel information is RGB 24-bit. So based on this, it's quite simple and straightforward for us to, in 10 minutes max, okay, to be able to kind of take your knowledge and adapt it to this particular problem. So let's go ahead and do that. So I have the BMP file. We know about unions, so I would like to access the data arrays are as structure members, so that's fine. Then later on in the future, we'll see how C++ allows us to do this better. But for now, I want to do something to the colors, right? So I want to show you, very simple experiment, just to kind of tell you, you don't need Instagram to do fun stuff. For example, yeah, I have this picture, right? I have another picture, and we want to manipulate, and I'll show you how we can kind of quickly do some quality stuff. Yeah, simple image processing. So I obviously open the file, and the reason I'm talking about all of this is because you're going to write some extensive command line parameter stuff. Normally I do that for you guys. So this semester I thought, hey, it's good for students to know how to do all this stuff. But I'll speak a little bit about the command line right after this in a moment. But this one is, got all the error controls. And I open the binary file, as you can see. It's a BMP file. You got to call the function with a BMP file, and the particular program that we are creating is going to create another BMP file that has some image, with the image processing implemented. Now, when you open a file, if the file doesn't exist, make sure you check for whether the file was properly opened or not. Sierra is obviously the third stream that is created for you when you begin your program. Standard input stream, cin, output stream, cout, and the error stream, cr. Now seek g. This is low level stuff, right? It's just like C. Fread, fwrite, fseek. What I'm doing is I'm shifting to an offset of 2 bytes. Why am I doing that? Because I look at the header, and the header tells me, the header tells me I need to be at an offset of 2 bytes to find out how many bytes there are, right, in this particular file, how many bytes of information there is. And I read the information. As you can see, we've seen the read and write in binary format, very low level. There's no other way other than to do it like I'm showing you. We got to cast and treat it as a sequence of 4 bytes, which I'm doing here, and I'm faithfully following, right, the information that is specified here, 4 bytes. So I'm reading no more than 4 bytes. And then just to confirm, I'm going to print out the size. Now I want to read the width and the height. right? Remember, we looked at the DIB header, and for Windows, and it said at an offset of 18, you're going to find 4 bytes that specify the width, 4 bytes that specify the height. So this is skipping all the bytes in between, right? And jumping to an offset of 18 bytes from the start of the file. And then I'm reading 8 bytes, 4 bytes for the width, 4 bytes for the height. And then, you know, we kind of do a sanity check and make sure that we are reading the proper stuff. Then remember, we want to actually grab the information, and I need to know how much. And so apparently at 10 bytes, so I mean, this is common, guys. You got to go skip up and down. There's no easy way. So at an offset of 10 bytes from the file, there is this particular 4 bytes are telling me where in the file the bitmap image is actually going to start, right? So if I want to read the actual pixels, then I need to read these 4 bytes. These 4 bytes will tell me in the file where the data is going to begin. So sort of like a convoluted pointer to pointer. So I position my file read iterator to an offset of 10 bytes. I read the information 4 bytes, and then I reposition myself to whatever is the value that I just read, right? And then remember, I know what the width and the height are, so I'm going to grab that much of memory. This is part and parcel of reading binary files. You need to be able to accommodate all kinds of BMP files, so you don't know what the width and the height would be. You read the file and then allocate the memory, and in one shot, pretty much read the entire information. So that is a nice thing. In one shot, we just finished reading, right? Because I'm providing the address and I'm specifying here how much, how many bytes to read. Obviously, width times height times 3, which is the size of the RGB structure. Now, you can do a sanity check like this, where I actually open up the image and use the photo viewer to position, to choose a certain pixel and make sure that the proper data was read. Now, I'm going to iterate through each element and process each pixel, right? Which is very simple. Basically, the simplest thing I can do is if the particular pixels our component is the largest, then I'm going to zero out the other components. If the green is the largest, then I'm going to zero out the red and the blue, and so on for the blue component. So you kind of get interesting, not grayscale, but monotonic sort of pictures, right? It's an interesting effect. Not a very clever effect, but an interesting effect. Now I need to create the output file because I converted the data that I have. And notice there's one tiny little thing that I'm doing. I have a 1D array, and this 1D array needs to be visualized in your program as a 2D array, right? And so we'll look at that part in a moment. And then I need to create the header. So I do some cheating here. I just take the header from the source file and dump it into the output file, right? Because I don't want to change the dimensions of the file. I'm not changing anything. So I just cheat and copy from the file that we are reading from the header information and dump it into the output. Then I close both files, make sure that I return the memory, and I'm done. And when you actually run the program, basically in 10 minutes, you can pretty much read any reasonable binary file, right? As long as there's no compression involved. So I made sure there's no compression in my files. So obviously you can look more at the file when it's online, but This is how it's going to look. And I'm going to take the pick 2 and pick 2 new, and it's a big file and it's printing, remember, some stuff for us, pretty huge file. So that's why it took a little bit of time. And this is the original file. And this is, wherever it is blue, we make it be blue, the green becomes the green, and so on, right? Monotonic. And, so it works pretty well, but this is the basic idea in terms of reading and writing binary files. Pretty low level stuff, but nothing complicated. Compression is a different thing, so I'm not going to worry about that. The next thing I want to talk about is I've noticed that many of you don't use scoped enumerations, and it's a shame because they're really good, right? And so the basic idea is that the old C style enumeration. So let me open a file to quickly show you what's the big deal with scoped enumerations. Okay, let's suppose you have an enum like this. I have no idea about fishes. Cod, herring, okay, and sardine. Okay, these are 4 fishes that I know, okay? And this is C style. Basically, you're creating a new type called fish. And this fish has 4 enumeration constants: salmon 0, cod 1, herring 2, sardine 3. Essentially, everything is an int. The problem, to continue doing this, which is really old C style, is that these names are going to be in the same scope as fish. And you created this type at the global scope. So which means throughout the entirety of this particular file, or if you do this in a header, everybody is going to be able to kind of, you're exporting these names. And that's the whole point of namespaces. Remember, we don't want to do this. So using C style enumerations comes with all of this baggage. So the better way to do this is to use scoped enumerations. So I'm going to do just one, and right, let's say you're writing a game. You're writing some sort of a embedded software system for traffic lights, right? They have their own state machine, but let's suppose you go red. No, how does it go? Red, yeah, red, green, yellow. It's been a while since I've driven. I haven't been back to Seattle because of the COVID, so no driving for a while. Okay, so red followed by green followed by yellow, right? So now there's no way for you to refer to these names anywhere unless you use this namespace. So these guys belong to this namespace called traffic light. Okay, is that the only advantage? No. In the summer, when I looked through the graphics course that I teach, and I looked at some of the code that people wrote in terms of UI, it seems like, that particular part can be easily, simply implemented by using the idea that this particular type is a user-defined type. And what that means is that in a user-defined type in C++, you can overload operators. So I'm going to show you that, this is fairly trivial. We can overload the prefix increment operator, which makes life easy if you're implementing code, right? For a menu, for example, I'm going to go from red to green. From green, I'm going to go to yellow. From yellow, I'm going to go to red. And if you have more states, then there's a lot more work that needs to be done with a bunch of switch statements and so on. Instead, what we can do with the new scoped enumerators is write code that looks like this. Now, these are not exactly similar to class based, so the overloading is going to look a little bit different, which is why you should pay attention. And I'm overloading the prefix, okay? We do pass by reference. All of us know that. And basically, this is what I do. Uh, if T is traffic light red, then I'm going to change it to be green, right? And since I have only a no, what I need to do is check for yellow. If it is yellow, I'm going to make it be red. Otherwise, if it is red or green, I'm simply going to make it be um, traffic light. And here, unfortunately, it's going to be a bit ugly, but forgive me for the ugliness that I bring to this particular piece of code. So these guys don't automatically convert to ints like these guys do. The type of red is always going to be enum traffic light, right? And there's no implicit conversion like in C in the old C++. So here I'm physically casting it to be of type T. And if it is red, it's going to have a value 0, to which I'm adding 1. And traffic light 1 is going to be equivalent to green, because that's what the value of green is. So this allows you to take that whole switch statement stuff, shove it somewhere else, and use code within your menu system that sort of looks like this. Traffic, actually, let's also overload the postfix before I write any code. Postfix increment, and obviously you can do decrement, so I'll just do this part. So you guys remember that with this one, we allow the compiler to distinguish by passing an empty, adding an empty parameter, right? The idea here is that int is always, going to be, since it's not used, we don't need to specify that. And the compiler will, in the background, call the postfix with an additional int, which we don't ourselves use. The problem is that if you kind of try to be nice and do this, then you're going to get all kinds of flag warnings because you're not using X. So best to do what I'm doing here. So here, all of you know, if you have attended my HLP2, we have a certain idiom in which we want to proceed. I implement the postfix using the prefix, which we have already implemented, right? So old, I'm going to make a copy, and then I'm going to increment T, right? So this is going to go ahead and call this function. Make sure you don't do this, because then you end up calling yourself, which is going to crash. And then you're going to say return old. That's it. So now, you guys should take advantage of these things because the code is easier. One thing you should remember is that the more you type, and when you come back and you're trying to fix bugs, you can't employ systems thinking, right? Because you see this whole bunch of complicated looking stuff and we can't wrap our heads around it. But when you kind of take these things and push them away, and then later on you write code that kind of looks like this in your menu system, then it's a lot easier to, how should I put it? Uh, kind of write code like this, right? So you have a traffic light that is currently red. And if there's some condition that arises, then you're going to make it be green, right? Of course, You can do this way too, but whichever way you use, you kind of reduced it not even to a function call, but instead to something that makes sense. I'm going to the next state. All right. And so I think you should prefer enum classes because they just cause fewer surprises and they make code be a whole lot more readable. And just so that we can confirm that this code is actually no. Where am I? Oh, uh, traffic light number 10. I'm not returning, of course. I got to return T, right? Why? Because I can write code that looks like this, but I can't do this. The compiler won't allow this. It's going to allow this because that is the difference between C and C++. This particular operator evaluates to a reference. And so we can continue to and do that. OK. So prefer that, guys, because it makes, I just think life a lot simpler. OK, then where do I go from here? Obviously, there's a whole bunch of stuff, pointers to functions. So I'm going to talk to you guys about that. Where am I? Function pointer.cpp. All right. Basically, we're going to do a whole lot of higher order functions in the coming weeks, but I just thought if some of you are going to end up working in a C style environment, maybe you don't use the, how should I put it, the standard C++ library, we still want to be pretty comfortable with function pointers. OK, so random is a function that takes an int and returns an int. So goes for add and dump. So this declaration, FP array, the way you want to read it is this. FP array, you move right, is an array of pointers to what? Pointers to functions, because what I see here is an opening and a closing parenthesis, and that can only mean a function. So FP array is an array of pointers to functions that take an int and return an int. That's exactly what these two guys are. So I can create an array of 2 elements and initialize. Some people call these jump tables. For lower level programming like embedded systems, these are called interrupt tables sometimes. Lots of different names, very, very commonly used, right? By operating systems, by pretty much anybody who wants efficient code. Now, all I have is just an array. And again, I didn't use C++ style constructs simply because I want to keep life simple. I'm printing the contents of the array, which as you can see is this. I'm adding a certain value to each element of the array. So I'm print. Then I call this particular function, right? Where A is the name of the array, size is the number of elements, and I'm passing a pointer to this modify function. And what is the purpose of this? Obviously, these particular array elements are going to be modified by the function that I'm supplying. And at different times, I have different arrays of different sizes being modified by different functions, right? So this is a pretty common construct in C and C++ too. So modify is declared like this, and it should be easy for you to see. It's an array. Since we want to change the elements of the array, it's simply of type pointed to an int. This specifies the number of elements, and the simplest way for you to read this is this unpronounceable thing is a function that takes an int and returns an int, but we can't pass functions. We can't have arrays of functions. So therefore, this pronounceable thing, OP, is a pointer to a function, right? And why do I have these parentheses? Well, if you don't provide the parenthesis, the function call has a greater precedence than the dereference. So the compiler will read this as OP is a function that takes an int and returns a pointer to an int. And you can supply functions. You can supply pointers to functions as parameters, right? So you can see here that I'm going through the array and applying this particular function. So it is looking a lot like what we did with the standard library algorithms, right? We're going to jump into that part in the coming weeks, but at the lower level, if you can't end up with a job where you program in C, a lot of these facilities, actually come from C. And that's really all there is. Does this make sense, guys? And I have some more examples. So here we can build calculators. A lot of projects that deal with Raspberry Pis and so on, right? They kind of look like this. So I have these functions. They all pretty much take the same parameters and return the same single value. So they're good candidates to be encapsulated in as array elements. So CA is an array where each element is a pointer to a function that takes these parameters and returns this. Again, if you get rid of this parenthesis, then the compiler will read this as CA is an array of elements where each element is of type pointer to a double, and then it comes across this and says, I don't understand any of this, and it'll flag this as an error. So that's why we put this so that it reads this entire thing as a whole. And the way it does that is it starts at CA, say it aloud, CA, then it goes right. CA is an array, then it goes to the left. CA is an array of pointers. This entire thing is done. So then remember, left, right, left. So it goes left. No, excuse me, right. CA, right, left, then right. CA is an array of pointers to functions. And then it skips to the left. And that is why C++ declarations are confusing. Because you got to go left, right, left, right, left, right. OK, and here you can see I'm creating an array and I'm essentially be able to jump to any particular function that needs to be executed because I'm using an enum to keep track of these operations. So add here matches add. Sub is the value 1, which is the subscript associated with the pointer to the sub function and so on. So this allows you to kind of jump around. Now we can create more fun stuff. So that's why I call it a fun pointer, right? And you will enjoy this. Fun pointer is a pointer to a function that takes this and returns this. Right now, fun pointer is pointing to the multiply function. So I call the multiply function. It's sort of like arrays and pointers. Sometimes we get confused. Same thing. When you look at this highlighted code, there's no way for you to know whether fun pointer is a pointer or the name of a function. OK, and that is the way things are. You only know fun pointer is a pointer because you can take your eyes and scan line 37. But this looks a lot like calling a function. So this is called duck typing. Anything that quacks like a duck, that walks like a duck is a duck. So pointers to functions are no different than functions. Then I change fun pointer to point to add. And notice I can build a slightly more complicated expression. So this is essentially calling the add function, but the add function takes two operands. So the left operand is going to be the multiply, right? The multiply takes two operands. The left operand is 3 and the right operand is going to be a call to the add, right? So I'm doing this. And then I'm doing this. So the entire thing is going to look like this. So we can do higher level of building of capabilities using pointers to functions. And that is actually a big part of where C++ is moving, right? It's called functional programming, but we'll look at all that stuff later on. All right. Are there any questions? Obviously, I mean, um, I had to kind of run through these, but you guys know command line parameters. There is a little bit of misinformation everywhere, and array command line parameters always look like this, right? If you call this program called program.out and you provide two pieces of input, okay, then you end up with an array of 4 elements. That's what argv is going to be. Argv is going to be an array of pointers to chars. And the last one is always going to be a null pointer. So we don't really need argc. You can iterate just using argv through each one of these elements. And this one uses argv, obviously, because uses both argc and argv, I should say. And you can see that. And the other one, I don't really care about argc at all. I can iterate through each element of this particular array using pointer arithmetic. And when I reach the last element, which is the null pointer, this particular condition is going to be false and I get kicked out. All right. And this is the part I wanted to talk to you guys about. Remember, I was able to kind of figure out, for example, C is an array of 10 elements where each element is a pointer to a function that takes a pointer to an int and returns a char pointer. And how do I do all these things? Well, because I have this algorithm that allows me to do that, and I'm going to talk about that at the very early part, okay, of next class, because I do want to complete it. So what is next? Next is a pointer to a function that takes nothing and returns this stuff. All right. There are more examples. Grape is a function. Grape is a function that returns a pointer to a function that takes nothing and returns an int. So I'm following the right left rule. Grape is a function because I zoom into the name, the identifier grape, and then I go right, always right. This is a function. So grape is a function. Once I go right, I have to go left. So grape is a function that takes nothing and returns a pointer. So this entire thing is gone. Pointer to what? Well, I go right again and I see the function call, right? So grape is a function that takes nothing and returns a pointer to a function that itself takes nothing and returns an int. And mango is an array of pointers to functions that take nothing and return an int, and so on and so forth. Kiwi is an array where each element is an array of ints. So Kiwi is an array of ints where each element is an array. No, I didn't say that right. I'm sorry. Kiwi is an array where each element is an array of ints. We'll talk about that. I'm rushing through. So the thing that we covered today is file IO, reading sort of like standard binary files by looking at information associated with file headers, getting to know function pointers, We have seen them before in the early part of this semester, in other semesters before, so it's not new, but there are more interesting things we can do. And if you've been paying attention to the class, then you're quite ready for the quiz. So the 35. So let me get to the quiz. As you can see, it was set up to be 20 minutes. I'm going to change it to, just because you've been good students, okay? 30 minutes. Hang on. Don't, I should have turned it on. And 30 minutes, right? And timing 30 and hide from students. Nope, show it. Okay. Refresh your pages and you should be able to see the quiz. 30 minutes is what you have.
Professor, you'll be disconnected from the Teams call once we use the browser. So
Go ahead and just finish the quiz. Right? I mean, not much we can do. Can anybody let me know if everything is working?
I'm still trying to log in with the safe browser.
You are able to?
No, I'm still trying to. I want to see if it's on my end or if it's there. Usually safe browser, some things works for me, but some things doesn't.
If
The safe exam browser seems to be taking a while to launch.
actually think of today as a test. Can I do the midterm this way, or do I force you guys to come to school? I don't know. I wanted to do a test.
You get invalid login.
Hello, Professor. Yeah, I also couldn't log into the.
Okay, don't worry about it then. Don't worry about it. It was supposed to be a test, okay? If you can't get in, you can't get in.
I'll try again in a few minutes.
Then basically what it means is that for the midterm and the final, you guys need to be in the school. That's the only way. Okay, if you can log in, don't log in, guys. There's not much we can do. Don't worry about it. When I said don't worry about your grades. Seems like quite a bunch of you. So what, all I'm going to ask you is, can you keep trying a few times just so that I'll have an idea of how things work? Okay, keep trying, guys. I just want to, we have like a few more minutes of the class anyways, so I'll leave the quiz as an open book quiz for everybody to participate in. But I just want you to try logging in so that I know what I can ask people to solve on the back end, right? Is it just spinning its wheels, or like can somebody speak? I mean, all I hear is a lot of pinging. Like, what's going on?
You can't log in.
No, I know. So you go to the save browser thing and then it just hangs.
Yeah, like so they'll ask you to put in your information. Then when you press login, nothing happens.
Okay. Okay. All right.
In my case, it's you put in the information, then it says it's the invalid login.
Yeah. Okay. No problems, guys. So don't worry about it. What I'll do is I'll leave the quiz for everybody to do as an open book, right? And then have to figure out what's going on. And for the midterm, we may actually do it in week 7, because then it's sort of like I can have all of you come in. There's quite a bunch of you. We need to kind of create a whole big system for you to do it in the school, because obviously it's difficult, right? And I'm hoping by then things get better with COVID. Okay, so basically I'm going to sign off. If you are unable to log in, don't worry about it. What I'll do is I'll make the quiz be open book. Seems like some people may have gotten in. Let them finish it. And then I'll make it be open book so everybody can actually use it for practice, and also sort of use it to make up the previous quiz where some of you may not have done well. Okay. That's really all there is. I don't want to rush through any more stuff just because I have a few minutes. Anything else, guys?
Hello?
Who's speaking?
Wait, just now I was able to log in if I downloaded the configuration file and then opened it from my desktop or wherever I downloaded it.
Well, that's the way it's supposed to. It says there, download the configuration file. So you did that?
Yes, because at
And it
first
worked?
I tried was to just launching the browser immediately. And then I was like, oh wait, maybe I should just go back and download the file.
So it worked?
At first I just tried to launch the browser immediately, so that's probably why it didn't work, because I didn't have the file downloaded. So maybe other people didn't realize that also.
But I thought all of you guys did that with other courses and my course, so all of you are familiar with this process.
Oh, no.
It says there very clearly, download the configuration file. Is everybody downloading the configuration file? Like Brian, Tay, is that what you're doing? Eldrin, Darian, Ernest, Tessa, you have to download the configuration file. Yep.
Hello, Professor. Hi, I also faced the same problem. I downloaded the configuration file. I ran it before the test, and I also couldn't log in.
What do you mean before the test?
It's when, as in like before the quiz, I downloaded the configuration. I ran the configuration.
How did you get access to it? If
as in before I pressed the launch save exam browser button.
Okay, so can you post the actual proper instructions to me so that I know what exactly I should communicate to everybody in the future?
No. I'm not sure what you're trying to say right now, but what I'm trying to say is that what we're saying is that some people may not have read the instructions, and therefore when they press launch, they can't log in because they didn't configure the Safe Exam browser. But what I'm trying to say is that I downloaded the configuration, and I loaded the configuration into my Safe Exam browser, and then I pressed launch Safe Exam browser, and I'm facing the same problem as the people who may or may not have read the thing.
So it didn't work for you.
Yes, it didn't work for me. Yes.
Okay.
Yeah, but it's inconsistent because I try again now, it works even though I didn't do anything different. So I think it might just be too many people at the same time or something like that.
All right, everybody gets 30 minutes, so go ahead and do it. So let me call out some names. Ernest, are you able to log in now? Nope. All right. So seems like it takes a little bit of time. Ernest, give it a few minutes and can you try? Just wait for a couple of minutes. Tessa Lowe, are you able to sign in? Tessa? Okay, excellent. Darian? Okay, seems like maybe the server is unable to handle too many requests. So it's not the setup. It could be the number of queries. So if somebody didn't get it to work, the proper procedure is just wait, right? No hurry. You're not losing anything because it's timed. So you will always get your 30 minutes. Okay. And just wait. If you have a class to go, just go ahead and get to that class. I don't have a problem if you want to take it some other time. It's not a big deal. But come back and
open for because I can't seem to access it now.
Who's speaking?
Jemima.
So what's going on, Jemima?
So I've downloaded everything, but I still can't seem to launch it.
You can launch the. Are you able to get to the login page?
Yeah, I can't even get to that page. But I've downloaded everything.
Then your setup is incorrect. Try just kind of, restarting your machine. The whole thing will take a minute, but it's worth trying. Sometimes if you just downloaded it before the class began, right? Maybe we need to restart your computer.
Because we have class later at 11, so.
Okay, give it a try at some other time.
Is it by the end of the day?
At this point, there's no specific end of the day thing. You can do it. Yeah, do it by the end of the day. How's that?
Okay, sure.
Okay, all right. Hey guys, if you have a class to go to, don't worry about it. I'll make the quiz again. So I'm actually going to leave, shut the meeting down, and like I said, I'm going to make the quiz be sort of completely open, and so I'm just interested in whether you can log in or not, and I learned a little bit today. So if you, many of you have classes to go to, just go ahead and continue.
You're making a new quiz, right? So if I just submit blank for everything, it won't be counted.
No, don't worry about it. Don't
Okay.
worry about it. If somebody has completed the quiz, then all they need to do is take the answers and copy it here, right? That's fine. Don't worry about it. All right. All right, guys. Thank you very much. I'll see you guys later.